Good morning. In today's video, we will be going over our new sensitivity analysis rollout in the crossings module uh, for the HDD PowerTool. So we historically or previously had sensitivity analysis in the PLTB under the crossings for gas and liquid. Under the crossings for the pipeline crossing, we had sensitivity analysis. Now we are expanding it to the HDD PowerTool, and you as a user, you will get access to sensitivity analysis study in both steel and plastic pipe for the pull force and insulation stresses. So briefly on a sensitivity analysis, the sensitivity analysis, what does is, it uses a broad set of mathematical approaches that are designed to quantify how sensitive or how variations in the model output may be attributed to the model input. These approaches they allow the engineers to assess how sensitive the underlying operational or the functional parameters are to the outputs or to the results, and essentially help mitigate and better plan the influence of these parameters in the model configuration and the model output. So for this particular example, what I'm interested in is I'm showing sensitivity analysis from the HDD PowerTool in the steel pipe for pull force and insulation stresses vertical. So as a user, when you come in, this is what you see as the widget, and it has been the same. Right at the top where it says HDD Power Tool, if you are a enterprise customer, you will see sensitivity analysis loaded. And this is how it loads, and this is how you see it. So let's say, if you're creating a new case, and this case, I'm going to create a case that doesn't have sensitivity analysis. I select an existing demo case that I have here. Here, this is the base case that we call. So in the base case, I have defined a bore profile. I have pull force and insulation stress analyzed based on the pipe configuration, the mud configuration, and the soil characteristics, and the impact factors. Basically, when I say impact factor, is the maximum load and the safety factor. All those things defined, and we have a pull force and insulation stress evaluated for this particular case, and it's a completed case. What I'm interested in is evaluating the sensitivity analysis for this base case. So for this, I go into the sensitivity analysis tab. Here we do have two options. We have the manual option and we have the automated option. For this particular section, I'm going to show you the automated version of this. So in automated version, the first step is the model essentially running all your input parameters that's contributing to your outputs, and seeing how sensitive each individual parameter is to the output. So let's say, outside diameter is one of those parameters that you have. The model is looking at a plus 30 and minus 30 variance by default for the outside parameter, and seeing how sensitive the output is for that. We do the same thing for all different parameters, and what you see here is the decision metrics that's being built up based on the evaluation done, and the decision metrics essentially has the top 5 parameters that's sensitive to the output. In this case, we have seen mud thickness, mud weight, outside diameter, SMICE, and insulation stress factors. Those were parameters. And the variance by default, we have it as 30. If you are a user who wants to switch it, you can simply switch it. When you switch or make a change in the variance, just click on the recalculate button, and it automatically recalculates the decision metrics for you. The next thing here is defining the parameter sets of interest for you. So the model has evaluated this is the top 5 parameters, so that's why it sees as the default one. If me as a user, if I'm not interested in one of these parameters, in this case, I'm not interested in mud weight, what I do is I delete that, and I can build my own 5 parameters that I want to study. So in this case, I'm saying I'm interested in studying the safety factor also as a parameter there. Now that's what my parameter selection for my sensitivity study is. Once that's done, the next piece is basically defining what my min and max and what are the number of intervals that I need. At any given point, we can support up to 1,200 unique cases that are built based on the base cases, and that's what you see here. In this case, there's a min value and max value that we default for each individual parameter. It's simply coming in from the base case. I'll tell you exactly how it is. So in this case, outside diameter, you have a min at 7.525 and the max is 13.925. So if you go back and look at our base case, our outside diameter is 10.750. So it takes a plus 30 and minus 30 variance for that, and that's what you see here as defaulted here. Now, as a user, I define what are the total number of intervals that I would like to see, and I select my intervals, and basically based on that, the model is kind of evaluating the total number of cases that it should evaluate based on that. So in this case, I'm going to say this is what my model input looks like, or the model configuration looks like. So it has 675 unique cases, and what I do as a next step is execute the calculation. So all these unique cases that we have built as pre-built are going to be executed in one single execution, and that's what you see here as part of the execution. Click on the create analysis, and you see a progress bar that essentially gives you an indication of where the execution stands. And it's currently executing, so you can see. Right. It has finally completed the execution, and what you see as the next steps here is a study summary that essentially gives you a high-level overview on how many cases have passed and failed and how many cases were executed. You have a heat map, and you also have a study plot. So what I'm going to do as a next step is I'm going to select a case that I have pre-built. This is the scenario analysis case that I pre-built here. I'm going to select this to essentially evaluate what the output looks like. So here, if you see, I mean, I had these are the four parameters that I'm studying against, and these are the total number of cases that we executed, and this is what the pass and fail looks like. And here is what you see as the heat map. And the heat map is a 2D map, so you select any two parameters that you want to define or analyze. In this case, we have selected wall thickness and outside diameter as the default parameters. I get to select any other parameters that I want. In this case, if I select smice and outside diameter, this is what you see here. And what you are essentially evaluating or seeing is as the outside diameter is increasing, you need to have a higher smice to handle the stress induced by the pull load. So those are the kind of analysis that's essentially helpful for you in analyzing your sensitivity studies to see, I mean, what is the maximum extent of variations that you can do for your operational parameters or the configuration parameters. So there might be scenarios where you are essentially evaluating multiple wall thickness and multiple outside diameter to essentially select the one that properly fits your case analysis. And sensitivity analysis is one of those things that can aid you to do that. The third piece here is study plot. So in the study plot, what we do is we essentially allow you to select any of the four input parameters that you're essentially studying the output against. So in this case, I'm selecting outside diameter as a function of total pull load to see where the pass or the fail criteria is. As you can see, the blue line is my calculator results for each individual intervals that I have, and the red is essentially the fail criteria that's being defined for each individual execution run sets here. And it fails as my outside diameter is going above the threshold here, and that's what you see here to see where it's failing. So what we have to evaluate or what we have to see is basically as the outside diameter is increasing, if we are using the same configuration as that of the one in the base case, what you're seeing is the wall thickness and the smice. If you're using the same, that's going to induce a threshold for failure there, and that's what you're evaluating against. So that's the study plot that you got there. And if you are evaluating against each individual point, you select that particular point that's of interest for you, and again select those parameters that you want to study it against. So that's also something useful. There are download buttons that we have introduced here for each of the plot. It's essentially allowing you to export the plot into a JPG file, so that's going to be used in your report. So that's something there. We also have an export data in an Excel that allows you to essentially export the entire raw data in an Excel format for your further evaluation. If you are a user who has created your case and you want to study or you want to save your sensitivity study, you click on the save button, and what it's going to do is it's going to capture your study along with your base case. So as part of you doing it, once you've saved your case, anytime when you're loading your case back, that sensitivity study is always available for you, made accessible for you, so that you can always come back to it at any given point. So that's also a feature that's there. So hope, I mean, you will like what we have rolled out. If there's any feedback that you have, feel free to just share it with us. Thank you.